Okay, there we go. All right, so I want to show you how to do Newton's method with something besides your TI-84 or TI-83, because not everybody has one of those. And thankfully, there are easy ways to do this, relatively easy ways to do this with programming. So I'm going to show you how to do this in Python. If you are comfortable with coding in another language, then you can probably take my code and adapt it to C++ or whatever. But here at ARCC, almost of our coding classes are in Python, or they're going to be. There's currently a transition being undergone there. So I want to show you the code I wrote to do this. So hopefully you are seeing now my Word document. This is a comment at the front here, so you got to be careful about what you change here. So actually, so all of this is comments. Basically, what you're going to do is go to this website called Repel.it, repl.it, which is the website you just saw a second ago, and we're going to code in Python. What you're going to do is take this entire document. You just hit Control A or whatever, copy the whole thing, and then come over here to Repel.it. Okay, so repl.it, hit Start Coding, and select Python. You could say what language you want, but I'm going to use Python. And hit Create Repel.it. So a Repel.it is like a little program that you run. So what this is going to be, this is basically a I forget what they call it, like it's an environment for running and executing, for writing and executing programs. But it's all in your browser. So this is nice. This is a great little website. And you have this document right here. This like big white space here is your main document. It's called main.py, and that's where you type your code. And then you can hit run at the top, and then the outputs are shown over on the right-hand side in this sort of black area over here. It looks like a terminal. So what I'm going to do, since I have just copied my program, I'm going to paste it in here. So there we go, paste it. So this is a program that's going to run Newton's method. Now, the parts that are in red here with the sort of triple quotation marks kind of surrounding them, those are comments. Those aren't actually part of the code. You could mess with them if you want to, but they're just not going to do anything. Don't change most things. There's a few small parts of this that I want you to change, but don't edit most parts. Like in this import math, leave it there. It's got to be there. The instructions here are enter the function f of x right down here after the word return. So it says we're defining f of x, and it's going to return means like basically the output of the function is going to be, and then type whatever the function is here. Now there's special syntax we need to use. So if you want to do like a power function or any sort of exponential expression, you can't just write a to the power b like with the caret symbol. What you got to do is math.pow and then in parentheses a comma b. It's always the base of the exponential expression comma power. So when you see math.pow x comma 2, that's how you write x squared in Python. And you have to write it that way because of stuff to do with data types. And when you're doing Newton's method, you need to be able to perform these exponential expressions with like the right data types, and it's got to be floats as opposed to just integers. So we got to use the math functions. So if you wanted to, so right now I've got x squared minus 2 as my f. So this is set up so that you have to calculate your own derivative. So the derivative of that is 2x, and so the derivative you enter down here, you can see it's defined as f prime. So you enter what that is here. And then the only other thing you want to change is your initial guess. So this is with an initial guess of 1, but you can change this value here to be whatever number you want. So then when you run, what it's going to do is say hit enter to calculate the next value, and then type stop to stop. So it gives you the first and second values. I actually thought it gave us, yeah, I guess it gives us the initial guess, and then it gives us the first value. So you can just hit enter to get the next one, enter, enter, enter. So this is, I think, the first example I went over in the videos was this one. So we're getting 1.414. This is the square root of 2. So say you wanted to change it. Say you wanted to do, like, maybe you wanted let's go ahead and stop. Oh, I forgot. You can just hit stop up there. Yeah. While you're running this, I programmed it so that if you type the word stop and hit enter, then it stops. But you can just stop it manually. All right. So let's say we wanted to do this with a different function. Like if you want to do sine of x as your f, you could replace this here with math.sine of x. Okay, that's fine. And then you have to change it f prime, of course, because the derivative of f of sine is cosine. So we do f cosine of x. And then maybe you want to change the initial input. So let's change that initial input to be 3. Right. If you watched my recent video, my last couple videos in this section, you know what I'm doing here, indicating myself. And then I think that should do it. Run. And we are now approximating the digits of pi with this application of Newton's method. And after a while, it starts to repeat itself because it's gotten so accurate that it's just getting closer and closer. It's not representing enough decimal places for the numbers to be different. So yeah, so I'm going to send you this code. You can copy paste it into a Repellent and then use this to perform Newton's method yourself.